Hello, my name is Robin Mitchell and welcome to this podcast for Electropages. In today's interview, we're talking with Murata, Juli Ban, I believe, and we're going to be looking at some soil sensors that they've decided to introduce to the market. So please introduce who you are, what you do, and what it is you like about engineering.
I'm from Murata, and my name is Juli Ban. Murata is kind of like an electronic component supplier, and we have a soil sensor. And this soil sensor can be contributing to the global issue like overpopulation and food security. To monitor soil conditions, and we can provide like a high accuracy of the data to the end customer and the farmers.
Now, with these soil sensors, my first question is, what measurements are they able to take?
Our soil sensor can be measured like the three different parameters, like soil temperatures and soil moistures, and also the electrical conductivity. Conductivity stands for a fertilizer amount of the soil. So by using these three different parameters, and the customer and farmer can optimize soil condition in order to maximize the crop yield.
And so you don't have, and so farmers can basically stop putting too much fertilizer into the ground or too much water wasting or not enough.
Yeah.
So the use of your sensors allows the farmers to be very, very efficient.
Yeah, right.
And so these sensors, are they standalone sensors or do they connect to another board like a microcontroller, or are they completely standalone?
We only can provide like a hardware, so I mean the soil sensor itself, but we have some partner who is like a kind of a system integrator to creating such an end-to-end solutions for agriculture soil monitoring system. Yeah, let's say.
Right. And one question I've got about the way that you measure electrical conductivity, with a lot of the sensors which I've seen in the market, the cheaper ones, they tend to use kind of like a direct measurement, but that tends to lead to erosion of the electrodes. How is it that Murata's sensor gets around this problem?
The function point of view, like the plant and crop absorb the fertilizer from the pore waters, so we should monitor kind of like electrical conductivity of the from the pore waters. But the EC of the pore water can be changed, not only the actual fertilizer amount, but also the moisture amount itself. And from our competitor point of view, it's quite difficult to distinguish these two parameters. This is kind of a dilemma, but thanks to our unique software and algorithm, we can distinguish these two values, whether it's affected by like a moisture or it's affected by true fertilizer. So this is a kind of like advantage and a unique point of our sensors.
But from the sensor's point of view, you've obviously got some prongs that go into the ground to measure these different factors of the soil. But those prongs, are they directly making contact with the soil with electrodes, or is it more of like a capacitive kind of sensor?
So it directly measured from the soil. So our sensor can be measured, implemented to the soil.
And are we measuring? So when you measure the electrical conductivity, is it using a pair of electrodes that you pass a current through, or is it a capacitive sensor? So there's no galvanic issues as it erodes over time.
So mainly, we are measured kind of like resistance between two electrodes, but we have 9 different electrodes. To minimize like uncertainty of the soil, because as you can imagine, like soil condition is quite different. Like there are some rock here into the soil, and also there are approximately like 32 different soil type in the world. So
it's quite a lot. And one thing that we saw just before we started this podcast is there was a mention of artificial soil. Could you give us a bit of details about that?
So yeah, just we released kind of like a new updated soil sensor for artificial soil because like the important parameter between organic soil and artificial soil is totally different. So we just
Right.
optimize our parameter like a software and algorithm to contribute artificial soil because artificial soil is quite mainstream for greenhouse and horticulture. So yeah.
And so these sensors, so what you're saying is that with the artificial soil, these are they tend to be used in more controlled environments where you might have an enclosed space, like with your greenhouses. And so these new sensors are able to distinguish the different factors in that soil because it's very different to normal soil.
Yeah, right.
When it comes to using soil sensors, what's the
Yeah.
biggest challenge that engineers and farmers face?
So yeah, of course, like let's say, the sensor implementation is quite sensitive. So I
Hmm.
think it's quite difficult to take care in order to receive the accurate data from the
Hmm.
our sensors. So yeah.
And so what you're saying is that sensitivity and accuracy are the biggest issues. And I can see that being an issue because if you have a large farm and you have different sensors, I suppose, do you have to average out the values, or do you find that certain parts of a field may have less nutrition than others?
So
It's a pretty tough question.
yeah, it's quite tough, but yeah, from design point of view, our
Mm,
sensor can be implemented to the soil.
mm,
So the end customer and then the farmer can keep to implementation into the soil by
mm.
using our sensor. So this is more yeah more big advantage compared with our competitors, and also
Mm.
some of like the outside compound is quite huge. So we have some the how to say connectivity method like
Mm.
LoRa one or cellular, yeah, together with our partner. So this is one of the big advantage and
Oh, actually,
unique features.
that's a good question. How does connectivity work? Because I imagine these sensors are wireless and
No, sensor is with wires.
with wires.
Yeah, with wires,
Yeah.
and then yeah.
And then how, and so if that's in the middle of a field, how do you get that data back to your receiving
So
point?
yeah, our sensor should be connected to the kind of like controller, and a controller to send it to the gate by the via like gateways. So the end customer can connect the data via like a cloud or a dashboard.
Hmm. And what connectivity options are there? Is it LoRa? Is it WAN? What kinds of technologies are we using here?
So yeah, we have some options like a LoRa and a cellular in this moment. Yeah.
And so by using those longer range technologies, it's easier for farmers to test larger fields in the middle of nowhere.
Yeah.
Yeah, that makes a lot
Right.
of sense.
Right.
And I have another question actually, which you mentioned earlier, which is what would you say is the biggest advantage that your soil sensors have over your competitors?
So yeah, our sensor can be implemented to the soil.
Mm,
So yeah, first of all, like our computer sensor is like a pole type or like kind of like a
mm,
probe type. So for this technology, it's quite difficult to how to say implement it to the deep of the soil. But in fact, like some of the customer would like to detect more deeper data.
mm.
Yeah, like 30 centimeter to 50 centimeter from the top because if so yeah, this is one of the big advantage, I guess.
And if there are engineers and farmers out there who want to deploy this solution, what advice would you give to them?
So of course, like in order to guarantee the data accuracy, I'd like the end customer to implement it our sensor correctly into the soil. This is one of the
Mm,
key because some of how to say when they implemented our sensor into the soil, if there are some how to say air gap and air pocket
mm,
between soil and the sensors, so sensor data is a bit strange, I guess.
Ah,
So
so you need to have a
yeah,
kind of
yeah,
you need a dense soil with minimum air,
yeah,
so the sensor makes
yeah,
complete contact with the ground.
yeah. Right, right.
Fantastic. Now, just before we wrap up this interview, is there anything you'd like to say to the engineers and potentially farmers who are watching this podcast?
So yeah, actually our soil sensor is quite new. So for organic soil type, we just released April last year, and for artificial soil type, just we released in this September.
Hmm.
So if you or like and the customer would like to evaluate it, just feel free to contact Murata.
Fantastic. Well, thank you ever so much for taking the time to see us today. Thank you very much.